All right, well, trust you did well on your first test of the school year. Students in here, for the most part, did very, very well. A few, careless mistakes here or there, some little things would like to see I improved upon, but for the most part, good. Hopefully you did well. Also, if you turn your textbooks to page 41, students in here are already there. We are going to spend the next week or so talking about fractions. And when I first say fractions, how many are instantly filled with a feeling of dread and doom? Okay, my goal is to help you overcome the dread and the doom, okay? Now, that doesn't mean you have to necessarily like fractions, but hopefully it won't be something that necessarily scares you. So today's lesson should be pretty basic. So we're going to start off easy for you, not make things too hard. First of all, what is a fraction? Mark that first sentence under fraction basics. Fractions are used to represent a part of a group or a part of a whole. Fractions are used to represent part of a whole or part of a group. For instance, in this classroom right now, I've got 11 students. 5 of the students are ladies. So we would say that 5 of the 11 students in the group are girls. 5/11ths. The top number tells you how many satisfy the condition of being girl, and the bottom number tells you how many total are in the group. If you take a typical pizza, how many slices in a typical pizza class? 8. Usually it's sliced in 8 slices. And so if Sam comes along, are you really hungry? He's really hungry. And Sam eats 7 of the 8 slices. Let's be honest. How many of you guys, if you ate the first 7 slices, even if you're full, you would see the 8th slice, you'd be like, I can't just leave one. And you would eat the 8th one as well. How many would do? Even the girls are raising their hands. Yeah, I'm the same way. Now, I can't do that anymore. I remember when I first moved here, first started teaching, I was fresh out of college. I was living by myself in my apartment. You get a Little Caesars pizza. The first 6 slices went down no problem. I can't do that anymore. I get to about 3 or 4 slices and I'm starting to feel full. But I'm getting older. But the first 6 slices go down no problem. Like, I'm not saving 2 slices. So I'd eat the last 2 as well. Then it'd be really full and have a stomach ache, and I'd regret it, but it's what it was. Gluttony maybe, I don't know. But anyway, Sam, however, eats 7 slices, and he leaves 1 in the box just to annoy somebody who might happen to see it. So 7 slices out of 8 total. 8 total slices, he eats 7 of them. The top number in a fraction is called the numerator. You see that term in your book. Mark that term. The numerator is the top number. The bottom number is called the denominator. Denominator. Note the spelling. Numerator and denominator. Okay, numerator and denominator. Okay, so it's not an ER ending, it's an OR ending. Class, what do we call the top number? Numerator. And the bottom number is called the denominator. Now, one of the things we've got to understand is that if, let's say, Sam was not such a pig, I'm just kidding, if he were not so hungry, and so he were not starving and wasting away to nothing, maybe he eats only 4 slices of the pizza. Well, we know this. If you eat 4 slices out of 8, see how my pizza cutting skills go, he eats 1, 2, 3, 4 slices. Well, he's really essentially eaten half the pizza, hasn't he? And we understand that we can reduce fractions down. And we always, write this in the side margin of your book, reduce fractions to lowest terms. We will always reduce fractions to lowest terms. Jot that in the side margin of your book. We will always make them as small as possible. So we wouldn't say, hey, I ate 4/8 of the pizza. He might say I ate 4 slices, but he wouldn't say I ate 4/8. He'd say I ate half the pizza. Because he's being a good friend, he's saving half for somebody else. Or he's saving half for tomorrow, who knows? All right, so half the pizza. All right, how do we do that? Well, the key is, and this ties into what we just talked about with greatest common factor. What is the greatest common factor of 4 and 8? Class? 4. They both have a 4 in them, don't they? We would divide by the GCF. Now, practically speaking, you're not normally going to prime factor everything and figure out what the GCF is and then divide it out. You're just going to be like, hey, I know I can divide a 4 out, right? So for instance, if I had this fraction, 10/15, we don't need to prime factor it. We know we can divide what out of the top and bottom class?
5.
A 5. We divide a 5 out of the top class, my numerator becomes a 2. Divide a 5 out of the bottom, the denominator becomes a 3. And so 10/15 reduces class to 2/3. Very good. Sometimes it's not as obvious if I had a 12/30. Now, if you take just a moment and think, what is the greatest common factor of 12 and 30? What do we have, Ben?
3.
3 is a common factor, but it's not the greatest. There's a bigger number.
6.
6. How many were thinking 6? Yeah, you could divide a 6 out, and that would be the best thing to do. Ben, for redemption, what would you get if you divided a 6 out of the top and bottom?
2/5.
But let's suppose that Ben doesn't see the 6, he sees 3. That's okay. We can still end up at a 2/5. What if we just divide the 3 out of the top and bottom, Ben?
4/10.
And then you notice, hey, those are still even numbers, class. I can still divide by. And by the way, I don't think we need to put the divided by 2. You don't have to do that. If you want to, you can, but you don't have to. I think we can think divided by 2. We get 4 divided by 2 is 2, and then 10 divided by 2 is 5 without writing it. We can still get to the 2/5. The key is this. Don't stop reducing until it's in the lowest terms possible. Sometimes it's going to be harder. Like, for instance, if I had the number 66/154ths, I do because I'm the math teacher. I don't know normally what the greatest common factor is. And do I really want to prime, let's be real, do we really want to prime factor it? I don't. But let's just do this. I can at least see they're both even numbers. So class, let's at least divide out a 2. Because we at least know there's a 2 in there. The numerator, of course, is the easier one. 66 divided by 2, Sam, 33. That one's not hard. Now, 154 divided by 2, that's a little different. How many times does 2 go into 15 in class?
4.
7 with how many left?
1.
How many times does 2 go into 14? 7. Now do we see another common factor, or maybe a bigger number this time, Paige? 11. I don't think we need to write divided by 11. Paige is smart enough to do this without it. What do we get if we divide the 11 out?
3.
And
7.
7. Turns out the GCF was 22. I think it's faster just to divide a couple of times. Divide by what you see, and that's where those divisibility rules come in so handy. You can see they're even, get the 2 out. You can now see the 11 from your 11 times tables, get the 11 out. So it's okay if we reduce in multiple steps. That's quite all right. Don't write this one down, just look up this way. 49/105ths. Looking at my divisibility rules, I'm coming up with nothing. But here's something, a strategy. What is the only factor of 49, besides 1 and 49, class?
7.
If this thing is going to reduce, then there's got to be a 7 in 105. I don't know if there is or not. Let's try it. Can 7 go into 10, class?
Yes.
How many times?
1.
With how many left?
35.
3. And 7 can go into 35 to get
5.
5. So if I also divide the 7 out of the top,
7.
7/15. Sometimes you can figure it out by picking the smaller number and thinking, well, I don't see it off the top of my head. But what can go into 49? Well, only a 7. Well, for this to reduce then, there's got to be a 7 in the 105. Does that make sense? Questions on reducing fractions. How many remember doing this in really 4th, 5th, 6th grade? Probably done it for the last few years. All right, any questions at all on reducing fractions? Turn to page 45 if you would. Flip over to page 45. I want you to do 27 to 41 the odd. Now let's practice making fractions smaller, reducing to lowest terms. Reduce until it can't reduce anymore by dividing the same thing out of the top and bottom, the numerator and denominator. Once you finish, pencil down, so that I know that you're finished. Looks like Michael's done, Luciana's done. Working. Bryson. One more minute to see how many of these you can get done. Again, reduce them all the way down. If you're already finished, check your answers. Make sure they couldn't reduce any more. Make sure you've got them as small as possible. Pencils down. Even if you're not done with all of them yet, check your answers to the ones you did get done. Let's see how we did. The first one, 2 7s, should have been pretty straightforward, Luciana. 1/2, just divide the 2 out. Number 29 shouldn't have been too bad, Bryson. 2/3, you can divide a 4 out. Now if you had 4 6, you should have divided by another 2. Number 31, what'd you get, Sam? 31?
I skipped out.
Skipped it. Do you see the common factor? Something that can divide out of 21 and 33? Jalen?
7, 11.
Well, the what are we dividing though?
3.
The 3, right? They're both on the 3 times tables, or you could look at the sum of the digits. So dividing the 3 out gives you 7 11ths. Let's go back to Sam for 33. What did you get for that one?
21.
I'm sorry? Okay, you're not wrong. You saw that they were even. You divided to get 9 over 21. There's still something that can divide further. Do you see it this time, Sam?
Yeah.
What is it?
It's, gotta divide by 3.
You could divide a 3, so we could get it all the way down to 3 7ths is correct. Good. Technically, dividing 6 would be the best approach, but if we didn't see it, start with the 2 and then use the 3. Number 35, Paige, what'd you get? Did not do that one. They're both even, right? So we know we can at least divide by 2. Let's start with that. What do we get if we divide the 2 out of the top and bottom?
11.
Over
20.
20. Can we divide anything else out? No, once you get to a prime number for either top or bottom, you know you're done, unless, of course, like this were 11/22 or something, but unless the prime number is what divides. So 11/20, and we're done there. How about number 37? What did you get for your answer, Corey?
8 9.
8 9ths, just divide the 3 out of top and bottom. And some of you are like, man, it really would help to know my times tables better. Yeah, it's true. Number 39, what did you get for your answer, Michael?
5 6.
5 6. How many saw the 12? You thought of your 12 times tables there. If you didn't, how many maybe saw a 6? Saw a 6 to get 10 12ths and then go down to 5 6. If you at least saw a 2, right, you get 30 36, and then Michael's like, yep, that was me. All right, so again, there's a lot of ways too you could have approached it, but ultimately ended up with 5 6. And then number 41, Kirsten, did you make it to the last one? What'd you get?
9 12.
Not wrong, but not done. You saw the 5 and got down to 9 12ths, but we can go a little further.
9.
What can I still divide out?
3.
3 to get?
3 over 4.
3 3/4. There we go. How many went 8 for 8? You got them all. How many got all the ones you did right? Didn't finish them all, but the ones you did, you got them all right? How many say, I didn't necessarily get them wrong, I just didn't finish on some of them. Like the answers you said, I just didn't take it all the way down. Right? That's something that we'll get better at as time goes along. And here's the deal. If I can reduce fractions by making them smaller, by, for instance, dividing something out of the top and bottom, does it make sense I could also reverse the process if I wanted to? And I could make fractions bigger. Let's look at making equivalent fractions. This is a big fancy word that just means eat the same thing. So for instance, 1/2. I can make equivalent fractions as long as I multiply the same thing by the top and bottom. So for instance, Ben, we might want to multiply the top and bottom by
3.
3 to get what?
3.
3/6, very good. Or Elaine might say, well, I would rather multiply top and bottom by
5.
5 to get
5/10.
5/10. Or Griffin might like to multiply top and bottom by 20 to get
20 over 40.
20/40. There we go, right? And you realize there's an infinite number of equivalent fractions you could make, correct? Jalen, you wanted to have one? What did you want to multiply top and bottom by?
11/22.
You wanted to multiply top and bottom by 11 to get 11 20 I was waiting for somebody to be like, 19,342? Okay, 19,342 over 38,684. Fine, whatever, smart Alec. Okay, but technically that would be an equivalent fraction, wouldn't it? As long as you multiply the... You already had one. Yes, what's your question?
Would 4.5 over 9 be an equivalent fraction?
It would, but it would also be what we call a complex fraction. I underestimated your nerdness. I thought you were going to go for a big number. You're like, no, I could multiply by a fraction. Could I do that? Yes, you could, Elaine. You could. She doesn't talk in that voice. I'm just picking on her. What about 5/9? What about 5/9? We could make several equivalent fractions with that. Corey, multiply top and bottom by. Pick a small number, Corey.
2.
2. There we go. And what would be an equivalent fraction, Corey, if I multiply top and bottom by 2?
10 over 8.
10/18. You got one last time, Jalen. Paige, what else could we multiply top and bottom by?
3.
Okay, to get what?
15 over 27.
Good. Or Sam might want to multiply top and bottom by?
5.
Okay, too late. 5 to get?
25.
Over?
45.
Hey, good job. 45 for me, you scared me. Or Bryson might want to multiply by? Smart man, to get what? 50 over 90. There we go. Okay, Lucy, I can't leave you out. I was going to stop there. We'll go one more. 12. All right, to get?
60 over 108.
There we go. Then you get the idea. Again, there's an infinite number of equivalent fractions we could make. Here's the key. Normally, though, when we make equivalent fractions, we're not just doing it to be crazy and fun, though it is fun to have fun and be crazy. Normally, there's an objective in mind. So, for instance, if I had the fraction 3/8, I might already have determined, Griffin, what denominator I want. I may specifically need to have a 32. This is going to happen more often than not, where you're going to need a certain denominator and you're going to have to rig the numerator to go with it. Well, in this case, instead of just arbitrarily multiplying top and bottom by something, you're going to have to figure out what did the denominator get multiplied by here, class?
4.
Apparently it got multiplied by a 4, and if that's what I do to the bottom, what you do to the bottom, class?
Yeah.
You gotta do to the top. So I also would have to multiply the top by a 4 to make what numerator, Griffin?
12.
12. So not just any old equivalent fraction, but specifically if you need the denominator 32, 12 32nds. Or for instance, if I had 7/11s and I needed a denominator of 55, what would the corresponding numerator have to be to make this work? Kirsten?
5.
Well, I'd have to multiply by 5 to get
35.
35. Does that make sense? How many remember doing this? Changing the numerator specifically to adjust to a particular pre-chosen denominator. Right? Questions at all on what we just showed? Did you still have a question? No. Yes, ma'am.
So, this is a hypothetical question.
Okay.
So, if we have a denominator that, you cannot multiply the top by, what would happen?
We're going to get to that when we talk about ratios and proportions, but as far as what we're going to work with fractions specifically, it will be something that where you can use an integer to multiply by. Yep, good question though. But we will address that. Yes, sir.
We have a decimal as a fraction.
Bruh.
Normally we wouldn't mix the two. Normally if you have decimals and fractions, you're going to move the decimal the same number of places in the top and bottom to avoid mixing decimals with fractions, generally speaking. Because you want to use one or the other and generally not both. All right, turn over now, if you would, to page 44. Actually, look across the page, I guess, to page 44. You were already on 45. I want you to do 19 to 26. Numbers 19 through 26, they've already pre-selected your denominator. You've got to make the numerator change to adjust with it. So figure out what specific thing was used to multiply in the bottom, and then multiply that in the top as well. Several students already finished. Good page, Elaine, Griffin. Play rock, paper, scissors against yourself. Don't play rock, paper, scissors during class. At lunch, play rock, paper, scissors all you want. Not during class. Meet you after school, we'll play for cash. I'm just kidding. Just kidding, I don't have any cash. By the way, I am accepting cash donations from those on YouTube. Okay, so send me. Just kidding. I don't have enough subscribers to qualify for a little thing. You know how when you have most channels, they have lots and lots of subscribers, and you can click to donate or whatever. Yeah, I don't have enough subscribers for that. So got to get to 1,000 subscribers, and then I can start monetizing. Just about 900 to go. All right. Anyway, I digress. All right. Though if you are enjoying my YouTube channel, and you haven't yet subscribed, help me monetize. Subscribe. Like the video. All the things that they tell you to do when you watch YouTube videos. Anyway. All right. Let's get back to class. I don't know what that was all about. Page 44, numbers 19 through 26. Number 19, what does the numerator have to be to make it an equivalent fraction, Ben?
8.
Well, the number you multiply by is 8, so what number has to go in that numerator spot?
16.
16. All right, so the equivalent fraction is going to be 16/40ths. Number 20, what number goes in that spot, Elaine?
5.
So what's the equivalent fraction?
5 over 10.
5/10. Number 21, what number goes in the spot there, Griffin?
27.
So what's the equivalent fraction?
27 over 36.
So we would say 27/36. All right, how about number 22? What's the equivalent fraction, Kirsten?
15 over 24.
So we would say
15/24.
very good, 15/24. Number 23. Now it's an improper fraction. That's okay. Jalen, what's the equivalent fraction?
20 and 10/30.
Well, it'd be 2 and 10/30ths, or 2 and a third if we were reducing. They just wanted the missing number, so we'd say 70/30ths. We actually can leave it as just 70/30ths. Does that make sense? Because they were looking for a specific numerator. But technically all of these would reduce. We're purposely not reducing. We're unreducing here technically. How about number 24, Corey?
99.
So that's the number in the blank. So what's the fraction?
99 over 110.
So 99/110ths. How about number 25, Paige?
10 over 12.
10/12ths. And then for number 26, Sam,
7.
goes in a blank. So the answer is 7/77ths would be our answer there. How many got all of them right? You got all of them right, or all the ones you did right, if maybe you didn't get all of them finished. All right, questions on that? Now, I used a term a moment ago, and I want you to flip back, if you would, to page 41. And we've got different types of fractions that we need to talk about. First of all, you see what's called a proper fraction, a proper fraction. If I say that there are 11 students in this class and 13 of them are girls, does anyone have a problem with that? Yeah, I normally have a sign, it changes every year what sign goes over that side, but last year I had a sign that said 8 out of every 5 students don't understand math.
Bruh.
And if you don't understand this, if the sign doesn't bother you, then you're one of the 8 out of 5, okay? So anyway, but you can't have 8 out of 5 people. That's just silly, right? That's what we call an improper fraction. So a proper fraction would be like earlier. 5 out of 11 would be proper. If you had 15 out of 11, that's improper. Basically, the numerator, if it's bigger than the denominator, it's improper. Now you might be saying, isn't that impossible? Well, not necessarily. Again, a typical pizza class gets cut into how many slices? 8. Well, let's suppose Sam hasn't eaten in 3 days. And he comes across a pizza buffet. And he knocks down 13 slices of pizza. He has eaten, then, class, 13/8 of a pizza. That is specifically showing he ate more than one whole pizza. He ate a whole pizza, that's 8 slices, and then he ate 5 more slices of the next pizza. One pizza plus 5/8 of another. So an improper fraction is used to show more than one whole. An improper fraction is used to show more than one whole. For instance, on the endurance run coming up on Friday. Students on YouTube are suddenly very glad they're just watching on YouTube. All right, endurance run coming up on Friday. It's okay, you're not going to die. I haven't lost anybody yet. Well, I mean, who knows the future? I don't. Was it college instructor for PEs used to say on the 12-minute run days, he said, make sure you eat bananas. Eat bananas for lunch. And I said, oh, because of the potassium, right? Help your muscles not to cramp. He's like, well, that's good too, but they taste the same going down as they do coming up. So it's all good to eat banana. Anyway, 12-minute run coming up Friday. But if one of the things at the end of the 12-minute run is if you can get that extra half a lap. Well, let's suppose Bryson's like, well, I'm going to feel better about myself. I'm going to count half laps. So he runs. There's 1 half. He gets all the way around. That's 2 halves. Gets around. That's 3 halves. And by the time it's all said and done, Bryson has run 9 halves laps. Now, that's not a very good grade, Bryson. We want to run more than 9 halves. But if he runs 9 halves, all that means that improper fraction means he's done more than a single half lap. He's done 9 half laps. Though we would normally change improper fractions into what are called mixed numbers. So we don't use the plus sign. We would just say 1 and 5/8. In this case, this would be 4 complete laps. That's 2 halves, 2 halves, 2 halves, 2 halves, and then 1 additional half lap. We would make this into what's called a mixed number. And you see examples of these here on the sides. As long as the numerator is smaller, class, we have a numerator smaller, class, we have a proper fraction. If the numerator is bigger, then we have an improper fraction. And if we have a whole number and a fraction together, we call that a mixed number, right? Okay, so that's what we're looking at there. Now, what's the key? How do we go from this to that, or from this to that? Well, you know this. What does a fraction bar actually mean, class? Divide, right? We did that with our order of operations, remember. We said fraction bar is a grouping symbol, also is a division symbol. Well, if you were to divide 13 divided by 8, class, how many times does 8 go into 13? Once, and we have how many left over? 5, and we would write the 5 as the new numerator, and the old denominator sticks around. Now that said, I don't think we needed to go to the trouble of writing it out this way. I think we can say, how many times does 2 go into 9, class?
4.
4. How many left over?
1.
1. And then you put the 2 down underneath. So for instance, if we had something like 22/8, let's just suppose this class, I had pizza for you guys, and somehow, okay, I limited you guys to 2 slices each, like the seniors do, which is just sad. Like, nobody can fill up on 2 slices of pizza. Okay, Chloe can. She's my oldest. She's only in 3rd grade. She could fill up with 2 slices of pizza. She's like this thin. But anyway, she needs to eat more than 2 slices of pizza, bless her. But anyway, 22/8. And let's say you all ate 22 slices of pizza. How many pizzas is that? Well, how many times does 8 go into 22, class?
2.
Twice. That's how many so far? 16. So how many slices left? 6, right? 22 minus 16 is 6. Over the original denominator, 8. But we always reduce. So we're now going to finish it off and say 2 and reduce it down, class?
3/4.
3/4. Okay, so we simply say, how many times is 8 going to 22? Well, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. I can't go in 3 times, it goes in twice with 6 left over, and then we reduce. Or if I had something like this, 13 sixths. How many times does 6 go into 13, class?
2.
2 times, with how many left?
1.
1, because 6 is 12, 2 sixes is 12, that leaves 1 left over. And again, the denominator remains the original 6. If this had been 43 sixths, how many times does 6 go into 43?
7 times.
7 times, so that's 42. How many left then?
1.
Just 1. And once again, we get a 6. So 7 and 1/6. It is possible, though, you might get an improper fraction like this, 21 sevenths. How many times 7 go to 21, class?
3.
How many left over?
None.
None. It is possible for improper fractions sometimes to become whole numbers, integers. And that's possible as well. But the key is you are dividing. How many times does the bottom go into the top? And that's for improper fractions only. Turn over to page 44. So actually, you're already on page 44, aren't you? No, I had to turn. Page 44. Very quickly, I just want you to do 1 through 6 at the top of the page. You're going to label each of those as either a proper fraction, an improper fraction, or a mixed number. So it shouldn't take you real long. Do 1 through 6 very quickly.
What if the numerator is the same as the denominator?
That's technically improper as well. Yeah, so if I had, like, for instance, 7 sevenths, we would just say 1. So 7 sevenths is technically improper also, because the proper way to express it would just be say 1. Like if I say 11 elevenths of the class passed their math test, which this is true, but it would be better to say everybody, right, rather than 11 elevenths. That's just weird, right? So. Oh, and I happened to pick the one that was actually in there. I didn't actually mean to do that. I just realized that. Oh, well.
Answer.
Yeah, there you go. You got the answer. Tricky moment, I'll tell you. I didn't actually say to look this way, did I? Oh. You can if you want to. Just don't hurt your eyes. All right, number 1, class, is a
Mixed number.
mixed number. Number 2 is an improper fraction. Number 3 is also improper fraction. Number 3, that's an number 3,
Oh,
improper. I heard somebody say mixed for number 3. Number 3 was improper. Number 4,
proper.
that's a proper fraction. Number 5 is a
Mixed.
mixed number. And number 6,
Proper.
what should we do, by the way, with number 6? We didn't ask us to, so we don't have to, but what would we do normally, class? Reduce it down to 2 sevenths, wouldn't we? I want you to do number 7 through 12 now. Turn each of those mixed number, or improper fractions rather, into either a mixed number or a whole number. Do 7 through 12. They're on page 44. Divide the top by the bottom. If you need to set up a division house, that's okay. Just remember the remainder becomes the new numerator. If you need a division house, that's all right. Most of these, though, I think you can do without the division house. Several people already done. That was fast. Yes.
What groups of food do we need to eat on Friday? Like protein?
Leading up to it, now for the actual at lunch, I would say bread is good, but not like sugary stuff. Sugary stuff kind of will leave you feeling drained halfway through the run. But breads, pizza is actually not a bad thing to eat Friday. Cheese is protein, calcium is good, sauce is not a problem, the bread is good. So mainly just stay away from sodas. That's the biggest thing that hurts you. On Thursday and Friday. The other days, it's not that big a deal. Yes, sir.
What about cheese?
Cheese is fine. Yeah. Just not too much, well, not too much on Friday because cheese can, anyway, yes.
I think we should mainly tell Bryson, stay away from sodas.
Yeah, I said that already.
I don't like
He heard it. If he chooses to ignore it, that's his suffering to come, not mine. I don't have to suffer. I mean,
Just watch it suffer.
exactly. All right, let's take a look at these answers together. Number 7, what did you get for your mixed number answer, Luciana?
2 and 3 over 10.
So how would we read that properly? We need to be comfortable with fractions. 2 and
3 tenths.
2 and 3 tenths. There we go. How about number 8? Now this one's tricky, Bryson. How many times does 6 go into 15? Twice, right? So that would be 2 with how many left over? 3. So initially 2 and 3/6, but what makes it tricky is we can't leave the 3/6 part. 2.5 is correct. How about number 9? What did you get here, Sam?
9, 15.
Not 15. Now again, if we need to use the division house, we can, Sam. But here's what I want you to think. How many times does 5 go into 9? How many left over? 4. I'm going to put the little 4 right there. How many times does 5 go into 45? 9. And it comes out evenly to 19 for our answer on number 9. Number 10, what did you get? Paige?
3 sevens.
I'm sorry?
3 and 3 sevens.
3 and 3/7 and perfectly read as well. Number 11, what did you get? Jalen?
Which one? I'm sorry.
Number 11, pay attention.
8 and 1/2.
8 and 1/2. Initially 8 and 2/4. Good job reducing it. 8 and 1/2. And then for number 12, Corey?
5 and 7 twelves.
Very good. 5 and 7/12 is correct. How many got all of those correct? Any questions on any of those? Need to see them worked? All right. Now, what if we want to go the other way around? And there will be times you'll have to be able to do this, where you'll have to take something like 4 and 2/9 and turn it into an improper fraction. Here's the key. Instead of dividing, we're going to multiply and add the numerator. So class, 9 times 4, 36 plus 2, 38. We're going to leave it over the original denominator of 9. So you multiply and add, and then leave the 9 in the bottom. So if I had 2 and 3/5, we're going to start by doing what with the 5 and 2 class? Multiply to get.
10.
And then what do we do with the 3?
Add.
Add to get.
13.
And we put it over the original
5.
5. So the 5 stays the denominator. What if I had a 12 and 1/3, Griffin? What would that become?
37. 37 thirds.
37 thirds is correct. Good. And what if I had something like 50 and 3/4, Elaine?
203 over 4.
203/4 would be correct, because we multiply the 4 times 50 to get 200, add the 3 to get 203, leave the original 4. Do we all remember doing this in years past? Any questions on making mixed numbers into improper fractions? All right, your seats do numbers 13 to 18. Do 13 to 18 now. Sadness. Wow, several people already finished. Ben, Jalen, Luciana, Elaine, Michael, Bryson, Corey. Paige. Sam. Griffin. Now let's fix them. All right, let's see how we did on these. Number 13. What is that improper fraction? Ben.
31 over 6.
So we say 31/6 would be our answer. How about number 14, Kirsten? No?
What?
Did not do that one. Okay, Michael.
59/7.
59/7. So 7 and 8 times tables can cause us fits sometimes. You put them together, it just is a mess. 59/7 because 7 times 8 is 56. How about number 15, Kirsten?
7, 7, 2, 7, 2.
For number 15, we're going to multiply the 2 times 12.
2 times 4 is 6.
2 times 12.
24.
Plus the 1.
25.
25 over 2. So 25 halves is what we should have had. How about number 16? Let me come back to you again, Kirsten. Just want to make sure you've got it. Not trying to pick on you here.
I mean 16.
Number 16.
For
I said
math.
Kirsten, didn't I?
Yeah.
Yeah, number 16,
Oh.
Kirsten.
45 over 6. 45 fifths.
Well, don't forget to add the 4. So 5 times 9 is 45. Add those 4 to get 49 fifths. There we go. How about number 17? Jalen wanted to help so bad. Jalen, go ahead on 17.
807 and 807 eighths.
There we go. 807 eighths. And number 18, Bryson.
133 over 10.
Good, 133 tenths is correct. All right, look at the word problem across the page. Word problem number 43. Read that for us if you would, Paige.
After the party, Mary had 43 slices of apple pie left. If each pie consisted of 10 slices, how many pies did Mary have left over? Write the answer as a mixed number.
Ah, okay, so she had a big party. She had a whole bunch of pies, and there were 43 individual slices left. Maybe she had them pre-served on plates, and not as many people showed up as she'd planned. I don't know what the case is, but if there were 10 slices to a pie, how many pies remain? Using a mixed number. Paige? Sam? 4 and 3 tenths. There are 43 slices out of 10 slices per pie. So there are 43 tenths pies. 10 goes into 43, of course, 4 times with the 3 left. So 4 and 3 tenths pies remain. And all I can say is I was obviously not invited to this party, or there would not have been 4 and 3 tenths pies left over. All right, questions on fractions. Just the basics that we covered today. We all still feel okay about fractions. Nobody's overly scared about what we did today, at least. So far, so good. All right, we'll see how tomorrow is, but so far, so good. Okay, that's good, good. Homework for this evening. Homework for this evening is to do page 46. Page 46, numbers 1 to 23. Page 46, numbers 1 through 23. Take a look at that tomorrow and continue our discussion of fractions at that time. Page 46, numbers 1 through 23. And have a wonderful rest of your day. You are dismissed.